Good morning, everyone, and welcome to today's session. So, yesterday we discussed about the Docker, and we discussed how the Docker solves the problem of packaging with an application and how we can optimize the application delivery using the Docker. So, that was the main purpose of using the Docker. And then we also discussed about how the Docker container can be limited in the resource utilization and how the signals that we are sending. So a separate disk space has been allocated to the Docker containers so that the signals that are coming from the containers are isolated from rest of the system. Okay, using the namespace and the C group functionality of the Linux kernel. So the question arises, if this is a Linux kernel functionality, then how come Docker can run on the Mac OS X and Windows? Okay, so we can run Docker anywhere if a Docker engine is installed. So any of the application that we have created using the Docker container will eventually run on the Windows as well as Mac OS X and Linux and all the flavors of Linux. So we see only dependency is a Docker engine, okay, and that is also known as Docker daemon. So the main thing is uh, how what architecture does it implements in the Windows and Mac so that it runs over there as well, because the kernel of Mac and Windows differs from that of the Linux. So Docker, when we implement the Docker engine, so there is a Linux kernel which is running in the backend over which the Docker is working. So even in the Windows, if we are running the Docker containers, it implements a Linux kernel, and that Linux kernel is actually it's doing the communication with the Windows kernel itself. Okay, that's how the containers are working in the that's the architecture for the Windows and Mac. There would be a Linux kernel that would interact with the further the kernel with the of the Windows and the Mac. This is how the Docker containers are implemented. All right, so let's try and understand about the architecture for containerization, how the containers actually run. Okay, so whenever we talk about the containers, the very first thing would be the physical hardware which would be running. So this is your actual physical hardware which is running. Okay, over that we are having a Linux kernel. So Linux kernel is implemented by the Linux distribution that we have installed. So we have must have installed some operating system which is having a Linux kernel built into it, and that operating system is running. Okay, so the Linux kernel is running and it's basically interacting with the hardware. Okay, this happens when we normally run any operating system over a virtual machine. So there is a Linux kernel being installed, and we as a user interacts with the operating system. All the operating system commands are passed to the Linux kernel, and that interacts with the hardware. Okay, now within this there is a separate space for the namespace. Okay, in the Linux kernel there is a namespace and there is one C groups. So C groups is also there. Okay, now there is a management console. Now what is a management console? Management interface is the one where we are typing our commands. Okay, like the operating system we are talking about. Okay, and over that operating system we are running our containers. Okay, so the containers form the topmost layer. Okay, so what happens is over the operating system we install the Docker daemon, and over the Docker daemon we are running the multiple containers. So multiple containers, if you will see, here is container 1, 2 and 3. Okay, So you can run multiple containers on one VM. Okay. There is no such limit of how many containers you can deploy on a VM. The issue comes when the resource utilization containers start using the resource utilization. So you will be limited only with the amount of RAM and the memory which is available on your system. Okay, like the memory and the cores which are available. So if a CPU utilization goes high, then you can't deploy any more containers on it like that. Okay. So that but if you try to run, let's say your application is not getting any requests and you are trying to run multiple containers, then you can run a number of containers on a system. Okay. And uh, this layer of the Linux kernel, okay, this is providing the functionality, namely the C groups and the namespace are allowing the containers to be run as a separate group. Okay. So if you will see, the C group constrains the use of resources. Okay, that is, it is limiting amount of memory and the CPU utilization and isolates the container from the rest of the system. That's why you will see that each container in itself is isolated. Okay, so neither the operating system user can access the resources of this container, neither the other container can access the other container resources. That's why, due to C groups and namespace in combined, they are running in isolation. So each container is acting as a separate instance for the application. Okay. Okay. So Pratik, what happens is, so Pratik has a question. Why do we require to deploy multiple containers in one system only? Okay. So Pratik, just think like, let's say this is your one big VM. Okay. And you are having just one application running into it. Okay. You deployed one application. Now, what happens? uh, when you deploy an application, let's say this was having a 16 GB memory, okay, and 4 core. So it's possible that your machine, okay, only sometimes in the morning, there is an exceeded number of users which are coming onto your VM, okay. At that time, this gets utilized, okay, but that window is only for 2 hours, okay. And so after 2 hours, what happens? Only like 2 GB memory is being consumed, okay, and one code processor. Now the issue is that you are wasting the hardware resources. See, only 2 GB and one core is getting utilized now after 2 hours. Only in a specific period of 2 hours, you were using the entire memory and the core, but after that, you are not using it. Or there is a consistent downward trend. So if you will look in an environment, mostly this happens is that the servers that you have configured are running idly. Okay, the resources are not being utilized, and because you have already created the server, they are continuously you are continuously wasting the resources. So what's the solution to it? See, if you deploy multiple containers, let's say we deploy 6 containers of 2 GB each to this machine, then those 6 containers can, in a combined way, utilize this machine's entire memory and the CPU. Okay, so that would be more effective than to run one application. Now we are running 8 application. We are using the full system resources, and we are putting the constraints like only 2 GB can be used. So, and we are running 6 containers. So we are ensuring that not more than 12 GB memory is being used. Okay. So we are providing some part for the operating system as well. So this allows us to use the VM resources much more efficiently. Okay, that's why I said, you are going to deploy the multiple container. Vishal, the green part is a combination of your operating system and the Linux kernel. Normally, when you install a Linux operating system, at the same time, the Linux kernel also gets installed. There is no separate installation of the Linux kernel. When you install the Linux OS, along with the Linux kernel, your operating system also gets installed. Okay. Pratik, main thing over here is we don't want to waste our resources. Okay. We want to use them as much as we can. Okay, so containers, when you deploy multiple containers, you will see that you are using the maximum of your resources which are available to you, because as I said, you deployed the 6 containers, so you were able to use the memory effectively, right? Otherwise it would have been wasted. What is the difference between C groups and namespaces? So, Samiksha, the C groups are limiting your resources, while the namespace is allowing you to create a separate disk space from which all the signals that a Linux kernel is receiving, okay, that will be acted as a different, uh, like a different resource altogether. That's why you are seeing that whatever signals are being generated within the containers are isolated from the operating system. So just think of it like this. Let's say this is one big space. This is one disk, one big disk. Okay. So names, initially all the disk space belongs to this operating system which is installed on it. Okay. Now, when we talk about namespace, so namespace allows this to take a part of this disk. Okay. And it will treat it as a separate disk, so that anything that we are storing over here, okay, inside the container is not accessible to this operating system. Okay, kernel will treat it as a separate. That's why you will see that any signal which comes from this part of the disk, this is being treated differently by the kernel. Okay, that's why you are able to run the containers over the same operating system which you are running. So it's possible to run the Ubuntu or like a Debian based operating system over a CentOS based system. That's a functionality of the namespace, and C groups when together are combined, we are able to we are able to create the containers, and at the same time we are able to put the resource limitation like how much memory CPU they can use. Okay. Anyone having any other question? The only difference, like in case of containers, you will see that it's not an entire virtual machine. Okay, so let me clear this. In case of virtual machine, you will see that a virtual machine comes with all the operating system binaries. There is like entire operating system to it, while if we see the containers, there is not much of the binaries, only very basic amount of binaries which are required to run the operating system is there. So if you want to understand this, like you can think of it like if we are installing a CentOS operating system, okay, the size of the CentOS operating system is 3 GB. Okay, so it comes with all these binaries and tools which helps you in troubleshooting, and you can do so many things on the operating system, but that might not be required by your application. Okay, so you don't want to install those binaries, so you create the containers. Now containers are not the complete operating system. Okay, so you can't directly install it over some server or over some virtual machine. What you need is a specialized containerization environment. Okay, that is Docker engine. That's a management interface. Okay, the management interface is your Docker engine, known as Docker CE. Once you have installed the Docker engine, then only you can run the Docker containers over it. So you see, operating system can altogether be installed, but they are bigger in size, they are bulky, okay, and they take time to come up and down. okay, and they use more resources, like your CPU utilization, memory utilization will be on higher side because you are deploying more dependencies now. But Docker containers are lightweight, they are small, and they can readily be shipped. Okay, that's the major difference between the virtual machine and the Docker containers. So virtual machines can install on an operating system, and over the virtual machines you can run the applications as well, but its size itself is bigger, they are slow, okay, because they are having huge binaries. Then they are having lot of binaries installed to them, okay. So it's not a very optimized way of running the applications, okay. But if we talk about the containers, containers are specifically designed to run the applications only. Whether or not you are having the operating system binaries, it doesn't matter unless and until you are able to run your application. So containers are designed like, especially if we talk about the Docker container, is designed from the point of view of the application only. We want to run the application, okay. That's the main part of the containers. Is it clear now, Samiksha? All right, any other question? All right, so now when we talk about the containers, they are mostly containing the binaries and the libraries. So it will have a very small number of binaries and libraries from the operating system point of view. Okay, there are Linux operating system available just of 5 MB in size. Okay, so you see it's very small, only a 5 MB of entire Linux is being used. Okay, it's a Debian based system developed by the HashiCorp. Okay, so you can use that Linux as well. So it is having a very small amount of operating system binaries and libraries, but it is having the complete binaries and libraries which are required by an application to run. Okay, so even if you install those binaries and libraries, its size is like 200 250 MB only. It's very small, right? So it's very compact and it's very easy to run these containers. You can deploy these containers anywhere, but it needs an underlying operating system on which you are going to install the Docker engine, and over that Docker engine you are going to install the multiple containers. Now because this virtualization is running multiple containers, you can use the operating system more effectively. Okay, there would be more resource utilization that you can achieve. If your application is not using the complete resources, you can deploy more containers, okay. And if it's using, then you can deploy one container. It's up to you now, but it leaves a space where you can deploy more containers if required, okay. And so the entire architecture for the Docker containers look like this. Underneath is the server or your real virtual machine, then you install the host operating system over that virtual machine, okay. Then you are having the LXC, like your LXC, we are here referring to the Linux kernel, like namespace and the C groups, okay. So we are having the Docker engine installed, and over that we are running the containers and the binaries. So we are basically running the applications. Now this operating system virtualization is not a new concept, okay. That is, the containers is not a new concept. It was introduced in 1982, way back. The only thing was that the containers were never designed from the application point of view. Okay, so if you will see, there was a ch root functionality where you can modify certain kernel parameters using the after ch root, okay, and you can't navigate inside the directories. That was the functionality of the ch root in 1982. Then come the free psd, then the lxc containers were there, then lxd containers were there, and later come the Docker. Now the Docker was the first container which entirely focused on running the application, how we can run parallel application on the same operating system inside a limited space, so that all the binaries run from there, okay. and that's why Docker got so much popular, and it's being used to package the application and run it anywhere. So once you have created your application with Docker, you can run that application anywhere. Okay, that's the main advantage of the Docker. Now, Docker containers are lightweight, that we already know, because they are not having all the operating system binaries. A very few operating system binaries are there. So if we talk about the CentOS, it's like only 150 MB of operating system binaries. Okay, rest are all the application binaries which are required by the application to run. So it's very lightweight. Okay, and so you can run the multiple containers on an operating system, and they all will run in isolation, so that one container resources are not being used by the another container resources. Okay, and each of the container is like a boundary in itself. Okay, in which your operating system is running, and your application can't cross that boundary, like the constraints which you have put, like how much memory to be used, RAM to be how much CPU to be used, and things like that. Okay, now whenever you have to create a Docker container, you need a Docker image. Docker image is like a blueprint of creating the container. Okay, so you need to have a Docker image from which you are going to create a Docker container. Unless and until you have a Docker image, you can't create the Docker container. Okay, so if we talk about, like, we know what is inside the Docker, we are talking that there is application binaries, okay, and the operating system binaries inside the Docker container. But what is outside of the container? So outside the container, okay, there will be other Docker containers running. There will be a Linux kernel, okay, and an operating system. Apart from that, there will be the Docker CE. Docker CE is your there is a Docker CE. Docker CE is your Docker daemon over which the Docker container is running. So it is also outside of the container. Okay. These are the four things which is outside of the container over which the container is running. Okay, and you can run the Docker on the Linux platform itself. You can use the package manager to install the Docker container. So you can use RPM or apt to install the Docker containers. And Docker is a functionality. Docker uses the functionality of the Linux kernel, which is namespace and the C groups. Okay, if we talk about the OS X, you can install the Docker over the Mac as well. Okay, so you can use the DMG to install the Docker also comes for the Mac, and you need to have at least 4 GB of RAM available if you directly want to install over the Mac operating system. Then you can install the Docker on the Windows as well. Okay, and Docker requires the hyper virtualization to be enabled over the Windows environment. Also, one of the important thing is that if you are trying to run a virtual box and the Docker directly on the Windows operating system, then you can't run both the technologies together, because both are the virtualization technologies, and there would be uh, issues that you will face that between if you try to use both of them together. Okay, so the solution over here is that how we are going to run, we are going to create a virtual box, and inside the virtual box we are going to run the Docker container. Okay, but if we try to run or Docker containers on the Windows and the virtual box at the same time, then there will be a collision, and we will be facing issues with both of the virtual box and the Docker containers. So we are going to run the Docker container inside the virtual box. Okay, is it clear to everyone? So you have the very first exercise would be to install the Docker on the Linux machine. Okay, so you can use the yum package manager, and you can run yum install docker ce, that would install the Docker. Okay, we are going to cover this part when we are doing the lab. Okay, then we are going to cover how we install the Docker containers. All right, so let's talk about the Docker architecture. Niteshri, which last statement, like how you install the Docker? Okay, so see, Docker and VirtualBox both are the virtualization technology. Okay, so if you are trying to run the Docker and the VirtualBox over a Windows operating system, okay, then there will be issue, uh, because both are virtualization technology. Okay, so both there will be collision, and you are going to face issue and the bugs in both VirtualBox as well as the Docker, so they can't be run together. Okay, so what we are doing is we are going to create an operating system like a virtual machine inside the VirtualBox, and inside that VirtualBox machine we are going to run the Docker containers so that we don't face this issue. Okay, so that's what we discuss about the VirtualBox and the Docker. Okay, so you can't run it both on the Windows together itself. All right, so let's discuss about the Docker architecture now. So very first thing and the most important part is that whenever you are working on any uh, host where you are going to run the Docker container, the very first thing that you need to do is install the Docker daemon. Okay, now Docker daemon is the most important part of the Docker containers. Unless and until you are having a Docker daemon running, you can't really install any of the containers. Okay, you can't run any containers because this is actually a runtime. Okay, runtime is something which is required to run an application, and here we are talking about the Docker. So unless and until you are having a Docker daemon installed on your system, you can't run any containers. Okay, now another thing is, whenever you want to run a container, you need to have an image with you. Okay, these are known as Docker images. So unless and until you are having a Docker image, you can't create a container. Okay, for creating a container you need a Docker image, and Docker image is like a blueprint. Okay, so these are like a blueprint for the container. So you need to have a blueprint for creating a container, which it basically have all the information like how these containers would be created. Okay, so that information is being stored inside the Docker images. Now if you visit the dockerhub.com, okay, so what is a Docker Hub? Docker Hub is a, you can think of it like a web application where you can find all the images for the Docker. By default, all the images goes inside the Docker Hub. So if you want to use any image like CentOS, Ubuntu, or anything, you can directly download it from the dockerhub.com. Okay, so that we call this Docker Hub repository. This is known as the public repository. Okay, why public? Because it's open to everyone. Anyone can download it directly from the Docker Hub, any of the image. That's why it is known as public repository. Here, it also supports the versioning. Okay, so you can create the different versions of your images and use them over the Docker Hub. Now, this is a public repository. Okay, but if you are running in your own organization, you can create a private repository as well, which is going to run on your server only. Okay, and it will be accessible to you because it's inside your network. Okay, so if you have installed some custom application over the Docker container and you are trying to create an image out of it, then you can store that image inside your own repository. This is a common case when we are deploying the containers. And during our lab session, we are going to cover how we can create the private repositories. Okay. So during the lab, we are going to create our own private repository. And once we have created our private repository for storing the Docker images, then we are going to pull one of the Docker images from the Docker Hub. Okay. And once we have downloaded the image, we are going to create a container, make some changes to it, and then we are going to push that image into our private repository that we have created. Okay, for us. This is how the Docker images are being stored. Now, once we have the Docker image, you can run the CentOS. Okay, so or this is basically an Ubuntu. So you can download the Ubuntu based image or a CentOS image or Nginx web server. Okay, so here in the diagram, here we are talking about the registry. Okay, and this is what is Docker Hub. Okay, this is showing you the Docker Hub registry. It is also known as registry. Okay, or repo. It's up to you what you want to say it. Okay, this is the Docker Hub. It is having all the images. It is having all the images, so you can directly download the Debian based system, or you can download the Nginx as well. So a ready-made image for the Nginx is there. You can just download it and create a Nginx container. Then you can download the CentOS. This is CentOS based. Okay, this is a CentOS. Now, what happens is whenever you run, like whenever you want to uh, create an Docker container, let's say we want to create this container. Okay, if we want to create this container, we need to have an image. Okay, so very first time we are going to run docker pull. Okay, this docker pull command is going to go to the Docker daemon. Okay, and this Docker daemon is going to check locally that if this image is available locally on the system or not. If it's not available locally, okay, then it's going to make a request to the dockerhub.com. Okay, there it will find this image. Okay, here is the image. Then its Docker Hub is going to return it to the host where we are running the Docker daemon. Okay, and that image will be downloaded onto the server. Okay, once we have the image with us on the system itself, then it's going to go ahead and create the container. Now the main thing is, unless and until we are having the image locally, okay, we can't create this container. Another important part is, uh, if you it will only download the image for the very first time. So next time if we create the more containers out of it, okay, then it will directly use this image to create the more containers. Okay, this is how Docker runs. For Docker pull is for pulling the image from the remote Docker Hub onto the Docker host. Okay, it downloads the image to the Docker host. Now, if we want to run the container, then we are going to use the command docker run. Okay, docker run will take an image and create the container. Okay, is it clear to everyone? So if you want to run a container, then you are going to use the docker run. If you are going to download the image, you are going to use the docker pull. Yes, Vishal's question is, can we create different containers like Ubuntu, Nginx on the same Docker host? Yes, Vishal, you can create as many containers as you like. Okay, and not only Ubuntu, you can run the CentOS and Ubuntu together on the same host. Okay, using the Docker container. Another thing is, let's say, how do you create these images? Okay, so if we some of the images are by default provided by the Docker Hub. Okay, these have been created by the Docker itself. These are the official images which you can use on the Docker itself. Now, this is a part of it because this is just a base image. Okay, this is just a base image with an operating system on it, but this is of not much use, right? We want to run our application, so we are going to combine. See, we are going to build an we are going to take a base image. Okay, plus we are going to add the application binaries to it. Okay, so we are going to deploy the application to it, and once we have both of them available, then we are going to run the application container. So if you want to create your own custom images which is having a base image plus an application binaries over it, then you can use the docker build command. Okay, docker build command uh, takes a docker file. Okay, now what is a docker file? I will cover that shortly. Okay, uh, you can think for the docker file as the commands that we want to run to create a docker image. So if you want to create your own docker image, okay, if you want to create your own image, then you will have to write a docker file. Okay, once you have written the docker file, you can run the docker build. It will take this docker file and going to create an image out of it. Okay, these are basically the steps that we want to execute for creating our docker images. Okay, so if you want to create an image, you are going to run docker build. Docker build is going to examine your docker file, and that docker file is going to create your docker image. Okay, once we have the images with us, we can create the containers out of that image. Also, we can push our images into the Docker registry. Okay, that is the Docker Hub, or we can push these images to our private repository as well, like the private Docker Hub registry. Okay, you can call it repo or the registry. It's up to you. Okay, so is it clear to everyone? Docker host and Docker client would be on different server. Manoj, no, there is no such concept of like the different servers. Okay, both of them are on the same machine. Okay, there is a chance where you can have the Docker host running on a different machine, but that is what we call through orchestration. Okay, that is a part where we are going to run the Kubernetes and the Docker Swarm, then this part will become effective that the Docker host is separate. For now, whatever we are doing, both the client machine as well as the Docker host, okay, both will be on the same machine where we are going to run the Docker. Okay, but when we are going to cover the Kubernetes and the Docker Swarm, then you will see that there are some machines which are dedicated to running the Docker containers, and you will execute the command on different machine and it will deploy on the different machine. Okay, that's an orchestration part, but for now both client and the Docker host will be on the same machine. The registry, this service, the registry is your hosted service. Okay, it's a hosted service. So it is being hosted by third party like Docker itself. They are responsible for managing these images. If you want to create your own images, you can create your private registry and then you can push over there. Okay, anyone else having any question till here? Guys, this is really important to understand because this is the entire thing that you are going to do with the Docker. Okay, so you are going to run the Docker containers. For that you need the Docker images. For running the Docker images, you need to have a Docker daemon already installed on your system that is going to pull from the registry and going to create the containers. Okay, I hope this is clear to everyone. So let's move ahead. All right, let's talk about the Docker images in more detail. Okay, now whenever we talk about the Docker, okay, so we were talking about the Docker CE or Docker daemon. Okay, so that Docker daemon is actually allowing us to create this boot fs. Okay, you see this, we need a dependency of Docker uh, CE or Docker daemon to be installed on the system. So that is actually enabling us to create this boot file system, okay, which is required to boot the containers, okay, and that is possible using the C groups namespace and the device mapper. Now, what is a device mapper? We already know about the C groups, we know about the namespace, okay. Now, what is a device mapper? See, whatever device that you have attached to your system, okay, that like even your disk storage, okay, that needs to be recognized by your Docker containers, okay. So you might want to provide an access to those external devices. That is being done through the device mapper. It maps all the devices which are attached to the kernel to the uh, containers, okay. That is the functionality. It's a virtualization thing. So Docker uses this device mappers to map the devices available externally to the containers, okay. And you are having a Linux kernel. This is a Linux kernel, okay. So this both forms your Docker daemon part, and it creates a boot file system. Now once we have a boot file system with us, okay, running, this is a dependency, okay, we can download the image. Like we have downloaded this image from the Docker Hub, okay. I already told you that images are on the dockerhub.com, so you can download the image from the Docker Hub. Once you download the image, it's downloaded over this boot file system and you can boot inside this image, okay. This will allow you to create an Ubuntu based container. Once you have the uh, Ubuntu based container, okay, you can add Emacs over it, okay. Emacs is a file editor. This is basically a file editor, okay. Just like the VI, you can add a file editor. Similarly, you can add Apache to it, okay. Now here the important part comes into the picture. The base image that we downloaded from the Docker Hub, this is a read only image, okay. This is read only, so you are not changing the image, okay. Instead you are downloading image, running this image, and over this image you are creating your own images, okay. So this is one image that you have created after installing. So you have created a read only image over this base image, okay. And over that image you have again created another image after installing the Apache. So this is an second image that you have installed over that base image. And once you have the Apache running, you are getting the signals request over this Apache. So it's a writable container, okay, where the logs are going to be written like that when you are going to get the resources. So what we see is that the base images are read only, and over that we can create our own images. Whenever we talk about the final product, so it's a stack, like a stack of multiple images, okay, and all are read only. So once you have created an image, you can't change that image, though you can create a different image over it, okay. And the final containers that we see, or the final image that we see, it can be a combination of the multiple images, okay, which has been stacked together to run the application, okay. Now you can once then you can start this container, stop the containers, and so on, okay. Clear to everyone? Anyone having any questions here? No, Pratik, that's a read-only image. So the image that you create does not overrides it, okay, the initial image that you are having, but it creates an additional image and it runs over that base image. Okay, it's like a logical grouping of the images. It does not override this base image. uh See, what happens is, if you are editing this base image, okay, let's say we install this Emacs and this base image gets editable, and later on we push to the Docker Hub. So now when the third person who downloads the Ubuntu based system, okay, he would be actually getting your Emacs and your Apache integration as well into this base image. Okay, but we obviously don't want this. That's why, from the architecture point of view, every image is read only. Okay, and you are going to create a stacks of it, because the functionality of what you are trying to achieve can be achieved like this, while it will not break the entire architecture. Okay, so once an image or a container has been created, see, this is from the uh, point of the infrastructure as a code practices. Like, whenever you have created a resource, it should be in that particular state only, and whenever you want to apply a change, okay, you will have to create a new resource. This is what we call immutable architecture. Okay, and you should not open the Docker containers and make changes to it, but rather you should create a new container altogether. Okay, why this is immutable architecture is needed? See, if I open a container and I make some changes, now later that container shuts down. Okay, it goes down and a new container comes into the picture. Now if it's a immutable container, okay, then every all the changes would be there inside the container, because it is present inside the image. Okay, and we have already created the commands, so image is created out of those commands. But let's say we edited the container and now it goes down, so we are losing out those changes, so we will have an outage in that case. That's why it's immutable. Okay, and that's why it's read only. You should never make a change to the containers like that. And images are read only, so you don't change the image, and when the later person downloads it, they are getting the original image. The image which you name, okay, will be having one of the base image. See, let's say we take this example, okay, and we name this image as custom v1. Okay, let's say this is a custom image, we name it as custom. Okay, so if we see this image, okay, this image itself will be comprising of three images. One is your base image, okay, of Ubuntu. Then it will be having a Emacs over it, okay, and then it will be having a Apache image. Although it seems to us like that, like it's one image of custom, okay, from the front we will see like this, but in the architecture it is a composition of three images stack over each other. That's what I mean to say that it's read only. This will become more clear to you from the next example. Let me just quickly take. So here it is. See, what happens is, whenever we create an image, we are provided with the image ID. Okay, so this is an image ID we are having. Okay, let's say this is of Ubuntu. Okay, then we installed the Emacs over it, so we get an another image ID. Okay, this is from Emacs, and it has been derived from the previous image of Ubuntu. Then we have installed Apache. Okay, so we again get one more email ID. Oh, sorry, one more image. Okay, image ID, and then we installed something like Java, so we get one more image ID. Okay, now if you will see that each image was actually created from the previous image. You are not editing the previous image, but creating a new image, and this new image is a composition of the previous image. That's why I'm saying each image is read only, and once created you can't change that image. So you are always going to create a new image, and then you are going to stack all these images together to create your final image. Okay, is it clear to everyone how the images work? All right, let's move ahead. All right, so whenever we are running the containers, we can use the Docker run. Okay, whenever we are going to run a Docker run command, okay, it's going to download the Docker image, and that would be downloaded from the Docker registry. Okay, that image, it will first look for the local copy of the image into the Docker host itself. But if it's not able to find that Docker image on the local server itself, then it's going to download it from the Docker registry. And once it's able to download it from the Docker registry, then you can create a number of containers. Now it's up to you. If you want to query the Docker registry, see, by default it's going to go on the Docker hub. If you are not going to specify anything, it will go inside the Docker hub. But if you can create your private registry as well, and if you specify that private registry, then instead of going to the Docker hub, it will go inside your private registry. Okay, and it whenever we create a container, okay, so an IP address will be assigned to that container. Okay, that IP address is a part of a private network which is created for the container. So when we do the lab, I will show you that each container is being assigned whenever we initialize containers. Each container is being assigned a IP address which is different from the host IP. Okay, so there is a separate network created for the containers through which containers can communicate between themselves. Okay, okay. So Vishal has a question. Yes, Niteshri, images can be of operating system or the application. Okay, you can create an image, your custom images as well. Okay, using the Docker build command. Are we installing each image or base image? So, Vishal, first of all, before you create your own image or create an application image, you will have to download the base image over which you are going to create your own image. Okay, so you need to have an like operating system image with you, then only you can deploy the application over that operating system image. Does that answer your question, Vishal? Niteshri is saying application, I mean here is software. Yeah, Niteshri, so you are having different software images as well. If you want to install Tomcat, there is a separate image to it. See, all the software vendors out there are themselves providing these official images where you can directly download from the Docker Hub. Let me show you. You can go to the dockerhub.com, Docker Hub. Okay, here is your dockerhub.com. And if we take a look over here, you will find that there are large number of hosts. See, I can search over here. I can search something like Nginx. Okay, so it will provide me all the options of this Nginx. This is an official Nginx, which is like the Nginx itself is providing to us. Okay, now these are the community Nginx, that is the different users who have pushed this Nginx images. Okay, similarly, I can search for MySQL. Okay, so here is MySQL images, MariaDB is there, Percona images are there, so you can directly download. Okay, and similarly, you have for Apache. Okay, some there is Tomcat, Maven, Groovy, Solar, Zookeeper. You see, all of them have provided their containers, so you are free to create download these images from the Docker Hub directly onto your system. Okay, and then run them. All right, so here is a command how you can download the CentOS image. So you can directly pull the image from the remote registry like Docker Hub onto your local system using the Docker pull command. So once you have successfully installed the Docker, you can go ahead and run the Docker pull command, and followed by the image name that you want to download. So in this case, we are downloading the CentOS image. Okay. Now, after CentOS, you can specify the version of the CentOS that you want to download. So there are multiple versions of the CentOS which are available, like CentOS 7.1, 7.2, 7.4, like that. Okay. So you can put the version here, or you can put the latest. If you put the latest, then it's automatically going to download the whatever be the latest version of the CentOS available on the Docker Hub. It's going to download that version for you. Okay. Another thing is, if you just write Docker pull CentOS, okay, then also it means the same only. That is, if you don't specify which version to download, then it's going to download the latest version for you. Okay. And if you want to run the container, then you need to use the docker run command. Okay, followed by the image name from which you are going to create that container. Okay, we are having the CentOS latest image, so we are running the docker run command to create a container of CentOS. Okay, so we have provided the image name followed by the command that we want to run. Okay, so here we are running the command who am I pwd date. Now what happens is, if you are having a command which gets completed when the container is created, okay, so container is going to stop. Okay, if the command gets completed, then the container is going to get stopped. So each time you run this docker command, you are going to get a new container. Okay, now if you want to keep the container running, then you should have a process which should keep running in the backend. Okay, that process should never get completed. It should run in a daemon mode. Then your container will continue to run. Okay, otherwise it's going to run and then it's going to stop after a period of time. Okay, so Vishal is saying, but I wanted to know, like, if we install Java on base image, so will it be treated as an image? No, Vishal, it's not going to be treated as an image. It's going to be treated as a container. Now it's up to you. You can create an image out of that after installing the Java. Okay, in that case, it's going to use the base operating system of let's say CentOS, and over that, if you have installed the Java, it's going to create a new image of your Java over that. Okay, as per my understanding till now, a Docker daemon gets Linux environment and any Docker image is built on top of it. Yes, Samiksha, you are right. So Docker daemon is the entire environment over which you require to run any Docker container. So whatever container that you are going to run, you are going to download an image, and from that image, whenever you are going to run a container, that is going to be run on the Docker engine or Docker daemon itself. Okay, which daemon process should always run? Docker daemon. Okay, Docker daemon is the process which should always be installed, and it keeps running in the backend. It's like a daemon which is listening to the on some port for the request. So whatever request that you want to send out to your containers, you are basically Docker daemon is listening them and sending out to your containers. This is how the containers run. Okay. All right. And let's move ahead. Okay, so if we want that the container should be running, and at the same time we can get inside the container to execute a command, okay, then you need to run it interactively. Okay, for that you will have to pass -i option to it, which will make the container run in an interactive way, so you can issue a command, get an output. Okay, and -t is used to get a tty to the container. Okay, so you can combine these two commands like docker run -i-t, the image from which you are going to create the container, and the command that you are going to run in the backend. Here we are running /bin/bash command. Okay, so this will allow us to get inside the container and issue the command interactively. Okay, but if you come out of the container, then it's going to stop again. Why? Because the bin bash command would get finished. Yes, Vishal. So you have to have different ports and the IPs of the containers. Now, because the containers are running in isolation, so it's possible that all the containers are running Apache on port 80. But if you map them to the host operating system, then each of the port 80 will be mapped on a different port. Okay, this will become more clear to you later, but for now just think of it like same ports can be used to run inside the containers because all of them are isolated. Okay, but if you have to, you will be receiving the request on the host operating system. Okay, in that case the ports will differ. Okay, now if you want to see all the running containers, then you can run the command as docker ps. It will show you all the running containers, and if you want to see all the running containers and the stop containers, then you can run docker ps -a. Okay, that -a command will show you the stop containers as well. Okay, and then if you want to get the details about how much resources is being utilized by your container, what are the upper limits and all setup for your containers, then you can run the docker stats command. So it's going to print all the stats about your container, okay, in the JSON format. Okay, JSON is your key value format. So once you run the docker stats command, it's going to print all the details about the container on your system. Okay, next comes how you can name your container. See, by default, if you don't name your container, Docker is automatically going to name your container with some comic name. Okay, with some comical name, it's going to name like Hungry Lumiere. Okay, so it's better to name your own your containers your own. Okay, so that you can easily reference to those containers. So how you can name your container? By passing the hyphen name and the name of the container, like docker run -it hyphen name, the name that you want to pass to your container. In this case, it's CentOS C1, and the image name and the command that you want to run. So it will going to name the container as CentOS C1. Now, what are the advantages of naming a container? See, you can either refer to the container with the container ID or the container name. So if you want to refer a container, you can directly refer it to by its name. And if you want to stop the container, then you can run docker stop command followed by the container name that you want to stop. And you can remove the container using docker rm command. Okay, that is for removing a container. if you want to remove an image of the container, then you can use Docker RMI. Okay, that will remove the image of the container. Now next comes the attaching. How do you attach to a running container? Okay, see, if a container is running in the backend, okay, and you want to get inside the container, then you can run the docker run command followed by -it. Okay, this will allow you to get inside the container. Okay, so you can attach to any running container using docker run -it, name of the container, image of the container, and bin bash. Okay, this will allow you to get inside the container. Or you can issue the docker attach command as well, okay, followed by the container name. It's up to you, both of them are correct. Okay, but the first way is the appropriate way to connect to a container, because if you attach to a container and you kill the parent process or PID1, then container is going to stop. Okay, so always use docker run -it, first command that we are having. Okay, now if you want to stop a container, there are multiple ways to stop a container. The easiest way is to issue the docker stop command. Okay, that will stop the container. You can kill the PID1. Okay, so if you kill the PID1, then also the container is going to stop. Okay, that's the main process which is running in the backend. So if it that stops, then everything stops. Now it's also possible to pause the container, okay, and to unpause it. So you can pause the container using docker pause command and the container name, and then you can unpause it using the unpause command. Okay. Samiksha is asking, how does the operating system forwards request to Docker? Okay. Samiksha, it uses the Docker commands that we are using. It uses the Docker API to interact with the Docker containers. Now, if you want to forward some web requests to the containers, then you can map the host, that is the ports on which you are going to get the request, using -p command that is going to come later. Okay, so you can specify the host port and the container port. Okay, just like how the vagrant treats the request to be sent to the vagrant machine, similarly docker containers also send it from the host IP address. So if I have to send a request, then I will make a request to the host IP, and followed by the port number. Then all the requests that will be received by that host on that port number will be followed inside, will be forwarded inside the containers. Okay, what is the application of attaching to a container? Samiksha, sometimes what happens when you are running the containers, okay, you get certain issues, like you want to check the logs, or you want to check if your code has been properly uh, like deployed inside the containers. Okay, so for that case, you are going to attach to a running container and going to see the logs or check whether your code has been deployed or things like that. Okay, although it's not required very uh, uh, commonly. Okay, but there are some scenarios for the troubleshooting purpose where you need to attach to a container. So Sanjay is saying, in case we did not keep container running, every time new container gets created, in this case, can container name may get repeat? No, Sanjay, normally the container names doesn't get repeat. Okay, and if you repeat yourself, uh, by default Docker engine it's not going to repeat, and if you try to repeat yourself like creating a new container, then it's going to give you an error saying the container already exists. Okay, you can start it like that. All right, so if you want to see all the running and the stop containers, you can issue the command docker ps-a. If you want to start the stop containers, then you can run docker start command, and you can restart a container using docker restart command. Okay, you want to remove a container, you can issue docker rm command that we already discussed. Okay, and if you don't know the name and you want to refer to the container name dynamically or container id dynamically, then you can run this dollar docker ps-aq. Okay. Okay, now the very important thing is, whenever you are running a container, okay, you always run the container in the backend. Now, what is backend? See, if you are going to interactively run the container, then you are going to get inside the container, and when you try to kill the process, the container is going to stop. But we don't want this. We want the container should continuously be running in the backend. Okay, and we should not be attached to the container unless and until we want to attach ourselves. Okay, when we want, because we already know the command for attaching to the containers, right? So we want that the container should start in the backend and it should run indefinitely, and if we want to attach, we will attach it manually at a later point. Okay, for that you have to issue -d flag with it. So you need to run docker run -d. -d is for running as a daemon, okay, in the backend. So you are not going to attach to the container, it's going to create and run in the backend without your terminal getting attached to the container. Okay, so we are going, you should always run the all the containers in a daemon mode. There is no requirement, okay, whatsoever that you have to run it interactively. So you should always run the container in a backend mode. So you are going to issue docker run -d, name of the container and the image of the container from which that container is going to be created. Now you can kill the container, that is send a term signal to the container using the docker kill command. Okay, or you can go inside the container and issue the kill command there as well. It's up to you how you want to kill the container. Okay, all right, next comes, so Samiksha, normally what happens is, if we talk about the vagrant, okay, vagrant installs the complete operating system. Okay, like we deployed the vagrant VM, so we saw that it installed the complete operating system, which was bigger in size. Okay, but if we talk about the docker containers, then it installed the container images only, which are very small in size. Okay, like 100 MB or so. Okay, so we are able to run the containers much more fast. Docker, sorry, the virtual box or the vagrant are actually using some backend virtualization technique and creating a VM, which are bulky in size. Okay, so it takes time to come up and down. Then it's not very scalable. Okay, it's not possible for us to install the virtual box on each system and then run. Okay, that's not, there would be networking issues as well. Okay, when we try to run in this way, because each virtual box will be on a different network and then they will not communicate with each other. So vagrant is a different approach which is used to create a test environment. Like us, we created virtual machines, but containers are altogether different from the vagrant. So Pratik is saying, Pratik, if you are having a container running in the backend and you want to like bring it in front end, by front end we mean that you are going to attach to the container. Okay, so you can run docker run hyphen it or docker exec, that is docker execute command hyphen it. Okay, the name of the container image and followed by bin bash. So it will take you inside the container and then you can do whatever you want to do. Okay, is it clear to everyone? All right, let's take a break of 10 minutes and then we are going to continue with our session. Okay, so let's take a break of 10 minutes and then we are going to be back. All right, so everyone back now. Should we start? Vishal, the Vagrant and the virtual box were created to create a virtual machine. Okay, so that is altogether different with the containers that we are going through. Okay, so not only Git we have done, we are going to do all the labs on the virtual box itself, Vagrant and virtual box. All right, so we were talking about the Docker images, and we saw how we can download the Docker images from the remote Docker Hub repository, and from those Docker images, we can create the Docker containers. Docker images are read-only images, and it's like a blueprint for creating the containers. Okay, so we can create the containers out of the Docker images. Arun, we are still going through like how about the Docker containers. So there is no lab session for today unless and until we complete the theory part. We are not doing the labs. Okay. So once we complete the theory part, then we do the labs. And this is applicable for all the sessions that we are going to do. Unless and until we know the technology, we don't want to do the lab because you will not understand anything what's happening in the backend. All right. So you can list all the images on your local system using the docker images command. Okay, and if you want to remove any image, then you can issue docker rmi followed by the image that you want to remove from the system. Okay, that will remove the images from the system. All right, next is if you want to install the package, how can you install some additional package onto your system, okay, on the container? So you first of all you need to run the container in the interactive mode and need to get a TTY on that container, okay? That you can do through docker run -it, name of the container and the image from which you have created the container, okay? Once you are inside the container, then you can, as usual, install the package using the yum. Okay, so you can install which nettools, and this will allow you to install the packages inside the containers as you require. Now, Docker allows you to create the images interactively as well. Okay, so you can once you have, like in the above example, we install which command and the nettools command. Okay, so you can run docker diff command to list what changes have been done inside the docker container. Okay, then you can commit the container. By default, whenever you commit the container, this image is going to be pushed inside the docker hub repository. Okay, and you can remove the container using docker rm command. Okay, so if you wanted to see the details of the different layers inside the image that we initially talked, if you want to do it practically, okay, then you can use the docker inspect command. Now when you run the docker inspect over the images, it will show you the uh, complete JSON and the different images and the format from which that image has been created. Okay, so it will print all the information about the image when you run the docker inspect command on that image. Okay, so how do you automate the Docker image build? See, whenever you are creating an image, one way is to run manually all the commands that you want to create inside the Docker. But this is not the infrastructure as a code practices. Docker allows you to follow the infrastructure as a code practices. So what you can do is you can create a Docker file, and that docker file is going to have all the commands and the process and the serialization in which you want to create the docker containers. It's like a blueprint to create a docker image. How you want to create a docker image, you can put that inside the docker file and then run the docker build command. It's going to analyze the docker file and going to create a docker container out of it. Okay, so for that, there is a particular sequence in which you have to write the Docker file, and then there are some of the supported commands which are supported by the Docker file, which you can use. Okay, so let's discuss them one by one. Whenever you are creating a Docker file, the name of the Docker file will always be the Docker file. This is by default. Only then the Docker build command is going to recognize the Docker file in your working directory. Otherwise, it's going to give an error that it's not able to find the Docker file. So you will always have to name it as Docker file only. Okay. Another thing is you need to use a base image from which you are going to create the your image. Okay, so you are going to specify the from keyword to specify which base image you want to use. Okay, like in this case we are using the CentOS image as our base image. Okay, so we specify the CentOS latest as our base image. Okay, and over that base image you can specify the maintainer. The maintainer is basically the person who is responsible for that image. Okay, so you can put your email ID so that anyone who is having who is using that image, okay, can reach out to you because you have created that image. Okay, if he wants any changes. Okay, next thing comes the shell command. You can directly use a shell command, and a shell command basically takes the input in the form of a JSON arguments. So you can pass all the parameters and arguments that you want to pass in the form of a JSON. Okay, so you can directly execute the shell command inside the Docker file, and the syntax is shown below. Okay, so you can run the shell command like this. Next comes your copy command. Now, copy command is used to copy a file from your host operating system into the Docker container. Okay, so in this example, we are copying the JDK, okay, RPM inside the Docker container. Okay, so you can use copy command to copy any of the file from your host operating system inside the container when the container is going to be created. So that command is supported by the Docker file. Another thing is you can use the regex inside the copy command, like we are using the star. So it's basically says like JDK followed by anything ending in .rpm. This is what this command means. Okay, so it's going to copy this RPM of JDK inside the Docker container, and then we can run that command inside the Docker container. Okay, next comes your add command. Add command also works in the same way like your copy command, in the sense that it also allows you to add the files inside the Docker container. So instead of copy, you can use the add command as well. Okay, so what is the difference between the add and copy command? Why two commands are there? Okay, see, the copy command will only copy the file. Okay, add will also copy the file, as well as you can, if you want to use or download from some remote URL. Okay, you want to download some binary from a remote URL, so you can directly specify that inside the add command, but you can't specify that in the copy command. Okay, so everyone clear what is the difference between the copy command and the add command? This is one of the most asked questions. Okay, then comes your run command. Okay, now whenever you are running any command on the Linux terminal, okay, so if you want to run the same command inside the Docker while creating the Docker image, so you can specify the run keyword for that. Okay, like if we are installing the which binary inside the Linux, so instead of directly running going inside the container, you can use the run command and specify the command. Now when the Docker file is going to be compiled and the Docker image is going to be built out of that Docker file, then all these commands are going to run during that time automatically. Okay, so you can run yum commands, RPM, it's installing the RPM. Okay, and then changing the directory to opt, creating a soft link for installation of Apache Maven. Okay, so you can specify all the commands that you will run on the system directly inside the run command and then followed by the actual command. After the run command comes your env command for setting up the environment variables. If you want to set up some path, like there is if you want to set up your Java home and the path directory, you can use the environment variable. Now normally you are also going to pass the passwords in the form of the environment variable. Okay, so those environment variables you can inject inside the Docker container, and then your application can call those environment variables to use them inside your application. Okay, this is the normalized architecture where you are what you are going to use inside the Docker container when you are creating an application in the Docker container. Okay, so you can use the env uh, command for that, and it will set up the environment variables for you inside the Docker container when it's going to get compiled. Okay, and next comes exposing your port. So let's say the port on which our application is going to run inside the container, you can expose the port for that. Okay, once you expose the port, that port will be available on the host operating system, and the request will be received from the host operating system inside the Docker container on that port only. Okay, so in our case we are exposing a port 22 for the SSH. So anyone who wants to SSH inside the Docker container can SSH over the port 22. Okay, all right, last one is your command. A command is a long running process which is going to run indefinitely in the backend. Okay, so you can specify a Docker command. Now, this command is different from the run in the aspect that run is just a command which runs in the backend and gets completed, while the CMD is a command which is going to run indefinitely, and this is why our container is going to keep up and running. Okay, this command will make sure that we are running the process indefinitely, like the min bash. So if it gets triggered, we are triggering this from inside the Docker container only. That's why it will keep the container up and running. Okay, that's the command option. So how do you build an image? Okay, now once you have written your Docker file, okay, then you can run the Docker build command followed by the tag with -t. Okay, whatever image name that you want to create. Like in this example, we are going to create a CentOS-Java image. Why? Because we have installed the Java on our CentOS VM, so it makes sense that we create our own image of CentOS Java, so that we can, whenever we have to create a Java application container, we are able to use this image directly. Okay, so you can run docker build -t CentOS-Java latest, and dot means current directory. Remember, you have to specify the directory, otherwise it's going to give you an error. Okay, now once we run this command, it's going to look out for the Docker file in the backend. Once it's able to find the Docker file, it's going to build that Docker file. Whatever is written inside the Docker file, it's going to get compiled, and your CentOS-Java image is going to be created, using which you can create a container. And whenever you create that container, on it the CentOS and the Java uh, machine, so the Java will already be installed on that CentOS. Okay, next comes your Docker registry. Now, Docker registry is used to store the Docker images. Okay, you can use the Docker registry to distribute the images. Why you will need to distribute the images? See, you there will be requirement where you have to create the containers on demand. So you are going to pull the images from your Docker registry. Another thing is users needs to exchange the Docker containers amongst themselves. Like one developer needs to share the application with the another developer, so they can use this Docker registry to push their Docker images. That's why you will have to have your own Docker registry, so that it's a private environment where developers can securely share the images between themselves. Okay, Now it's up to you. You can use the hosted image like image registry like the Docker Hub, or you can create your own registries as well. Okay. Now, obviously, there would be some considerations while creating the registry. It should have the performance, like the images should readily be available and it should quickly download. How many images you can store, how many, what's the rollout frequency, all of these things needs to be considered. Another important aspect is the security, because it's running your application code, so you can't share these images with the outside world. Okay, otherwise they might find out the bugs, or your code might get leaked, which might be used by your competitor, so you don't want to create those security kind of issues. Okay, so it's better that you have the access control in place and you are digitally signing the images, so that you know that this image was created by you only and it's not a malicious image which is running something in the backend. Okay, that is very important from the security point of view, and that's the reason that you shouldn't use any of the community based images, because you don't know what that image is running. You should always use the official images provided by the official distributors like CentOS, Ubuntu, Nginx. Okay, you should not use the image which has been created by some other user, because that might pose a security threat. Okay, and we already covered about the Docker registry, how we can push the images to the Docker registry, and it supports the versioning. Okay, and you can distinguish between the different images on the basis of the versions. You can specify a version for each image that you are pushing, so you can push the same image with the same name to the Docker registry but with the different version. Okay. Now, Docker Hub is the default registry. For that, you don't have to specify anything. If it's not able to find the Docker image locally, then it's automatically going to go inside the Docker Hub. Okay, you don't have to do anything for that. That is built in into the Docker. If it's not going to find the image, it's going to go and look out for the remote image inside the Docker Hub, and then going to download it locally on your system. Next is you can apply the labels, okay, on your Docker containers. The labels are basically the URI. URI means Uniform Resource Identifier. These are basically the fully qualified domain names. Okay, so you can apply the labels onto your Docker containers, and then you can refer to all the containers inside those with those labels. Okay, that will help you to isolate the containers altogether. Okay, like if you want to specify the particular containers with a specified label, like that, it's similar to that of the tags. Okay, so you can specify the label, and then all the containers would be available for that application like that. Okay, so you can specify the labels as well. All right, so there are number of Docker registries which are available. So if we talk about the cloud providers, they have created their own Docker Hub registry, like the Google Container Registry, Amazon EC2 Container Service. Okay, QA is there, then the private registry is there. So we are not going to use any of the cloud provider registry. What we are going to do is we are going to create our own registry from the scratch. Okay, we are having an image for the registry pre-built, so we are going to create a container and that is going to run our registry. Okay, and then you can log into the Docker Hub using your Docker command as well. So if you are having your registries inside your Docker Hub and you have purchased the subscription, that is buy the license of the Docker Hub, then you can log in, provide the credentials to the Docker, that will log in inside your Docker Hub automatically over the command line, and then it would have access to the images which your user is having. Okay, that's how the enterprise version of the Docker works. All the credential information is being stored inside your home directory of the user through which you are running your Docker containers. Inside that, Docker creates a hidden directory of .docker. Inside that, it creates a config.json where your credentials for the Docker Hub are going to be stored in an encrypted way. Okay, so the password would be hashed out. Okay, hashed is a random number generator that would be assigned using some algorithms, which will encrypt your password so that any other user can't uh, look out for the password that you have used. Okay, this is how Docker can access the images inside the Docker Hub. Okay. All right. So how do you use a Docker Hub repository? So you can create your own image using the Docker build command. Okay. Once you have created your image, then you can commit the image with the name that you want to commit inside the Docker Hub. By default, it's going to commit the images inside your Docker Hub. So you don't have to do anything extra. Just run the Docker commit command and the image name that you want to push with. Okay, once you have done the commit, then you can push your commit into the Docker registry. Like here we are pushing the image with fill/question, so it will push our image as a fill/question, and then any other person on the Docker Hub can download this image directly from the Docker Hub. Similar to this, you can push this image to your own private repository as well, which is what we are going to do in our lab session. So we are going to create a private registry, we are going to create an image, and then we are going to push that image inside our private registry. Okay, so how do you pull an image from the Docker registry? So you can pull the image from a Docker registry using the Docker pull command. Okay, that will download the image from the Docker Hub to your local server. Yeah, Sridhar, some of the commands you will find they are similar to the Git because the functionality of the Git has been built inside the Docker containers, right? The versioning and the commit and the push are all from the Git itself. Okay, and then you can delete the images using the Docker RMI command. Okay, that we already know. So what are the private registries? We already discussed about the public registries, but we can't push our images directly to the public registry, otherwise they would be available for the third party users. Moreover, you have to buy a license for the Docker Hub. If you don't want to purchase a license, then you can create your own registries. The advantages of the private registry is that it doesn't have to go to the internet to look out for the images. So if you are under some uh, regulations that you can't push your images on the public registry, then you can create your private registry. That would be more faster because you don't have to go to the internet. You are just working on the intranet right now. It's inside your local network. Okay, so that would be much faster as compared to the working over the internet. So the network will work more faster, and for that you can pull a registry to image. Okay, that is available in the Docker Hub. Once you pull the registry to image, you can run this registry image on the port 5000. Here we are running the registry image in a backend daemonized way. Okay, using the -d command, -d flag, and then we are specifying the port. Okay, the host port and the container port, like what port we should receive our request on the host, that will be forwarded inside the container. So both are 5000 in this case. The name of our container, that is registry, and the image that we are going to run, so that is again registry. Okay, so it will create a registry container which is running on the port 5000. We can send a request to this registry container and store the images inside this registry container. Okay, so I was the 5 MB image that I was talking to you. Okay, that was the Alpine Linux. You can use the Alpine Linux, that's just 5 MB in size. Okay, and then you can tag the Alpine. So first of all, we are downloading the Alpine image, then we are tagging the Alpine image as our local host repository because we want to push the Alpine image inside our private repository. Okay, so we tag it as localhost 5000 to identify that it is running on our local registry and as an Alpine lattice, then we can pull and then we can push it inside our local host which is running on 5000 port. Okay, the registry which is running on 5000 port, this is a remote host address. Okay, and slash alpine to push the image inside our local repository. So we are pulling from the Docker Hub, we are changing the name of the Alpine Linux and then pushing inside our private registry. Okay, this is what we are going to do practically as well. Okay. All right. Now comes Docker networking. Okay. So let's talk about the Docker networking. Now, whenever we talk about the containers, the networking is an important part of the Docker. Okay. So we can have a default networking or a user-defined networking. Now, the user-defined networking we are going to cover when we are going to do the Docker Swarm and the Kubernetes. That is a user defined networking. Okay, in which case we are going to create our own networks. Okay, so that kind of networking we are going to cover in the Kubernetes. That is an extensive networking which you are going to use in a production environment. Okay, but if you are directly running the Docker on a host, then you can use the default networking which is being provided by the Docker itself. Okay, so in our case, we are going to use, there are basically three types of networking which are available to you. This is your bridge networking, a host networking, and a none type networking. Okay, so we are going to cover all the three networking in detail. Okay, and remember, user defined networking we are going to cover when we are going to cover the Kubernetes. Okay, and for now, we are only covering the default networking which is provided by the Docker itself. Okay, now whenever we install the Docker, so Docker automatically creates three default networks on our server. Okay, and that is your bridge networking. Okay, a bridge networking is the default networking and it acts like a bridge between your host networking, the network in which your host is working, and your containers is working. That's why all the containers are accessible from your host. Okay, so it has created a bridge between your containers and your host. That's why both are working with the same networking. Okay, then comes your host network. Okay, now whenever we use the host network only, so it assigns the same network that our host is running to the containers as well. Okay, now that is not of much use because the communication is not possible in that case. Okay, so the host network is the one in which the containers are using the same network as the host on which they are running. Okay, so it is using the virtual machine network only. And then comes your none network. None is basically your local network. Okay, or local to the container, that is your local host on which if you are running the containers on your local host, then you can use the none network, in which case your containers will only be accessible from your host only. Okay, but you won't be able to forward any request to your containers or things like that. So these are basically the three types of the networking which is available inside your Docker containers. Now you don't have to do anything extra for installing this network. It by default, whenever you install the Docker containers, it automatically gets installed. Okay, along with the Docker itself. Okay, So you can run the docker network ls command that will show you all the available networks which have been installed on your system. Okay, so it will show you the output similar to this. So each network will be assigned a network id, that is a unique identifier of each type of the network. Okay, and the scope of each networking. Okay, by default the scope of each networking is local, that is it's only available for your local VMs. That's why you will see the docker networking by default is not sufficient enough, and that's why we need the additional orchestration engines like Kubernetes and the Docker Swarm to run the Docker containers if we are running in a production environment. Okay, so this networking is only available locally and it's not ready for running the full-fledged production environments where we are having the extensive requirement of networking before we can send and propagate the request to the containers. Okay, so here is a bridge network for you. If you will inspect a bridge network, you can get the details of any type of container using the inspect command. We already discussed about this. And because these are a special type of containers which are running, okay, so we will use the docker network inspect command. Okay, and you can inspect the bridge networking, and here you will see that once you inspect the bridge, you will see that there is a separate subnet which has been assigned to the docker containers. Now subnet contains a range of IP address which can be assigned to your containers. Whenever you install the Docker, by it will automatically create a default subnet. Okay, in this case, the subnet it has allocated is 172.17.0.0/16. Now, if you install the IPNet tool using the yum as discussed in the previous example and do an IP if config, then you would be able to see the IP of your container. Okay, and that will belong to this subnet. Now, how much IPs or how much containers can you create using a /16 subnet? So you can create up to 32,000 uh, net containers using this subnet. Okay, it's a very big subnet, and the gateway always the first IP of the subnet is reserved for the gateway. Okay, so here the gateway is 172.17.0.1. Okay, so next comes your bridge networking. Okay, now the bridge networking is a bridge between your host operating system and your container network. Now the IPv4 address for our containers, we already know the subnet. Okay, and it will determine our MAC address and going to create a bridge from our host to the containers network, and this is the default type of networking which gets enabled between our host and the container network. Okay, and also if you will closely analyze your container, you will see that whenever you log in inside a container, okay, and you check the etc host file of that container, you will see that there is an entry of a container IP followed by a container. To resolve the container ID, see this EB6 is a container ID. So what this etc host file is doing, it's resolving the container ID to the IP address so that we can refer to the container ID and it will automatically get resolved to the container IP. Okay, clear to everyone? This happens only in case you are using the bridge networking for your containers. Okay, guys, want to take a break at this point? Okay, So let's take a break, okay, for 10 minutes, and then we are back, then we are going to continue with the containers. Okay, so let's take a break of 10 minutes and we will be back, then we are going to continue with the Docker. All right, so everyone back now. Let's continue ahead. So we have seen how the during the bridge networking, how we can the Docker will create an entry inside the Docker container in the etc host file, or mapping the Docker ID to the IP that has been assigned to it by the Docker networking. Okay. Okay. Now, by default, what happens whenever we are creating a container over or Docker container over a host, then it will be having, then it's automatically gets attached to the host network and has the same network and access to the same network as that of our host. So we can request any of the web requests will come onto the host IP address, and it will forward the request inside our container through the bridge networking. Okay. Now, none network is only in case if we don't want any of the networking, so that our container is not accessible externally, but rather only to our host. Okay. So in that case, there will be no communication between the containers, and only the host network can access the container. Okay. Next comes your user defined networking. Okay. Now, what is a user defined networking? It mostly comes into the picture when you are going to create your own network. Okay. Now, your own network is mostly done so that the containers which have we have created on the multiple machines can interact with each other. Okay. Now, user defined networking is being supported by the orchestration tools like the Kubernetes and Docker Swarm, which is having different networking. So we are going to read about multiple networking which are available inside the Kubernetes, and then we can use them so that an completely dedicated networking is being established between the Docker containers, so that each of the containers which gets deployed onto the multiple VMs are able to interact with each other, just like our virtual machines are able to do. Okay. For that, we are going to cover the Kubernetes. All right. And if you want to create your own network inside the Docker Swarm, okay, that is, you don't want to use the network which is available from the Docker, which it by default creates on the VM. You can create your own network as well. Okay. For that, you can create a network using the Docker network create command and the name of your network. So in our case, we are creating a network as isolated bridge. Isolated bridge is just another bridge that we are creating, bridge type networking we are creating for our containers. Okay. So this time not using the default network which is created by the Docker, but rather creating the containers in the network which the user has created. Okay. And so it if you will do the Docker network ls, you will see that an isolated bridge network container has been created. Okay, this is similar to the previous bridge network, just that it has been a custom network created by us. Okay. All right. So if you wanted to create containers inside this network, then you can use the docker run command, which is used to run the containers. So you can do docker run -it hyphen network. Now this time you will have to pass the hyphen network additionally, because you have created an additional network. By default, if you are not going to pass the hyphen network, then it's going to create the containers inside the default type of networking, which is the bridge network that has been created by the Docker itself. Okay. And this time it's going to launch the container inside this isolated bridge networking, and then the name of the container that you want to create, like we are passing a Java CentOS based container inside this isolated bridge networking. Okay. And then you can use the docker network connect command to connect to this container, okay, which has been launched inside the separate networking. Okay. And you can delete the network using docker network rm command. Okay. Okay. Next comes your Docker Compose command. The Docker Compose is a tool to run the multiple containers in your Docker application. So whenever we talk about the microservices, we are having multiple containers, and you might need to run these multiple containers to bring up your application. Okay, in which case you at least needs to run like 8 to 10 containers simultaneously. So a Docker file will help you to create each container, but then uh, if you need to bring all the containers together up simultaneously, so you can also do that using the Docker Compose. Okay, now Docker Compose allows you to manage the multiple containers, so you don't have to perform the commands manually, but rather you can use the Docker Compose and it will bring up all these containers simultaneously for you. Okay, so you can create a YAML file, specify everything inside that YAML file, and when you run the Docker Compose, it will bring up multiple containers together itself. Okay, so your application will be running and you can manage the life cycle for the containers directly using the Docker Swarm. Oh, sorry, Docker Compose. Okay, now you can install the Docker Compose. It is available as a binary, so you can directly make a curl request and directly download the binary of the Docker Compose from the GitHub onto your local system, and you can just copy the binary inside your USR local bin. Okay, then it will be available to all the users on the system. Okay, Docker Compose, and you can make this Docker Compose executable uh, as well. Okay, and Docker Compose by default reads the docker compose.yaml file. Okay, so you will have to create a docker compose YAML file. Also there you need to create a build directory. Okay, so whatever application that you are running, you will have to create a build directory for your uh, Docker Compose, and inside that build directory you will have to copy the Docker file as well. Okay, and you need to write the Docker YAML. Then this Docker YAML file is going to build that application automatically. Okay, so like in this example, we are creating an SSH service. Okay, so here we are going to install the SSH daemon on our network, so on our container, so that we can directly SSH inside the container. Okay, this is just an example of how to run an application inside a container. Okay, and how to use the Docker Compose. Okay, but you are never going to do the SSH inside the container. Okay, so here first of all you specify what is the version of your application that you are building. So we are creating a version 2. Every time you create a new version, just increment the version by 1 automatically. Okay, just change this version inside the Docker Compose file. Okay, and then you specify the services which you want to create. In this case we are creating an SSH service, so we specify SSHD. The build type is SSHD. This is the service that we are going to build. The image from which we are going to create this service, so we are creating it from CentOS -sshd latest, and the ports that we want to expose on our host as well as inside the container. Okay, so on host we are going to use 2222, and inside the container we are going to expose on 22 port. Okay, so this is our Docker Compose file. Okay, now once we have created this, okay, you need to create a Docker file, and you need to first of all create a directory named as SSHD, and inside that SSHD directory you need to copy the Docker file. So below is a Docker file to install the SSHD on the container. Okay, and so we are going to create a Docker file for it, as like we are going to use the CentOS operating system. Okay, then we are going to use the yum to install the OpenSSH server, create a directory for SSHD, add a user. Okay, and set up the user password, and then we are going to generate a key and expose over the port 22. Okay, this container for SSH service to run, and then we are going to run the SSH daemon in the backend, which will continuously uh, listen the request on the port 22, and then whenever it receives a request on the port 22, it's going to allow the SSH inside the container. Okay, this is what this Docker file is doing. So we are going to create a directory named as sshd, and then we are going to copy this as a Docker file inside the sshd directory. Okay, now once you have done this, okay, that's all you need to do for the Docker Compose to bring up your application. So you can, at this point, you can directly run Docker Compose up -d. -d is for running the container in the backend. Okay, otherwise it will bring up the container in the front end, and you will see all the logs and everything inside the container. So just run Docker Compose up -d, and it will automatically bring up the container. Now you can specify as many containers, okay, as many applications as you want inside the Docker Compose, and whenever you are going to run the Docker Compose, all the containers are going to come up. Okay, so you can use the Docker Compose to create entire dev environments, staging environments, production environments, and whenever you issue a Docker Compose, it will bring up all the containers. So Manoj is asking what is the difference between the Docker Compose and Docker file. Now, Manoj, Docker file is used to create a Docker image. Okay, but once a Docker image has been created, you will still have to create the Docker containers out of that Docker image. Okay, and if you are having an application which is using multiple containers, then you will have to do all of this thing manually. Okay, if you want to automate all the stuff, so that just with one command, that is Docker Compose up -d, your entire dev environment should be up and running, or your stage environment should be up and running, then you have to use the Docker Compose. Okay, the Docker Compose is also going to use the Docker file to create the image. Once the image has been created, then it's going to use the Docker Compose file to create the container and expose the ports. And once everything has been done, then all the containers will be up and running, and your application will come up and running. That is the main use of the Docker Compose command. Okay, to bring the entire environment up and running. So normally, Vishal, what happens is whenever you are running the Docker Compose, all the applications that you require that are of the same type. Okay, it's usually to bring the entire environment up. Okay, whether it's like dev environment, production environment, so there can be multiple applications inside it. So you can bring the entire environment up. If you just want to bring the containers of the same application up and running, okay, then you can create only those builds inside those folders, and the separate builds can be created inside the separate folders. So only the containers which you want will come up. Okay, you can just differentiate between the containers on the basis of the directory that you are creating, and organize your Docker Compose file according to that. So only the containers belonging to the same application will come up and run. This is mostly used when you are running the microservices. Microservices compose of many small containers. I discussed this in initial sessions. Okay, so usually if you have to bring up the application, then there are like 10 to 12 or even more containers that you have to bring up. Okay, so all those services are dependent on each other, then you can use the Docker Compose to bring them up and running. Okay, and you can bring the entire network down using the Docker Compose down command. It will bring the entire environment down as well. Okay, that was about the Docker Compose. next comes your docker run command. Okay, the docker run command is used to create a container, and it allows you to pass the name hyphen hyphen name to uh, create a name to the container. Hyphen p command is used for assigning the ports to the container. You can get a tty using hyphen t command, and hyphen hyphen rm command is to remove the container. Okay, Samiksha is asking, why would you SSH from Docker Compose? We are not doing SSH from Docker Compose. Samiksha, we are bringing a SSH daemon, that is an SSH service, live on a Docker container. Okay, so it's just for the demonstration purpose of, if you want to enable an SSH service inside the container, you can do it. And then instead of doing it manually, we use the Docker Compose to bring up the SSH service. This is not just for SSH. You can deploy the web servers, database servers, anything like that. Okay, through Docker Compose. All right, that's all about the containers. Okay, so we are still left with time. If you want, I can start with the lab today itself. Okay, else we can do it in the next session as well, because we are not going to complete the lab today. So let me know if you want to start the lab today. Okay, let's start today then. Okay, it's not only about installing, we are going to create the containers as well. Okay, okay, so I see a mixed reaction between people. Some want in this session, other wants in different session. Sorun is saying let's do it the lab on full length. Sujit is also saying for next week. Bala is also saying for next week. Yes. So guys, just remember that even if we start today, we won't be able to complete this in half an hour. Okay. So I would suggest that we should complete the lab the same day. It would take around at least 1.5 hours to complete the entire lab. Yeah, we can go for question and answer round. Okay, that's not an issue. So anyone having any questions, you can ask now. Okay. I can take an additional after the Docker, we are going to start with the chef. Okay. If you want, I can brief you on the configuration management tool. Okay. Before ending the today's session, and then we perform the lab and start with the chef in the next session. So, Nitishri, the issue that you are reporting, that the VM is in the booting state, this is a known issue. This happens when the virtualization is not enabled on your laptop. Okay, for that you will have to boot into the BIOS of your laptop and enable the virtualization over there under the advanced option. Okay, once you have enabled it, then you would be able to boot. Vishal, you don't need to download anything. Just get one VM up and running. Okay. And inside that, we are going to install the Docker, and then we are going to run the containers over that as well. Okay. There is no as such prerequisite. We are going to start from the scratch itself and then build out the entire Docker lab. Okay, and we are going to create the private repositories, pull the images, create the Docker file, create the Docker compose file. So we are going to perform all of those things. Okay, yes, so just one CentOS VM. Okay, CentOS 7.5, use the same VM as we did in the Vagrant session. Okay, don't I would not suggest to move on to the different VM, because although Docker remains same, okay, but you might get into some other issues, and then we don't want to like focus on troubleshooting those parts, okay. And so Kunal, the requirement for running Docker is that you need to have Docker engine or Docker uh, daemon to be running on the instance that we are going to install using the package manager like yum, okay. That is the only requirement. All right. So that is about the Docker. Let me brief you on the configuration management as well, and then we can end because we are not having the time for the chef as well. So I would like to brief you on the configuration management, and then we are going to end the session. Okay. Because next time we are going to start with the chef as well. Okay. So can you please compile a list of steps starting from Vagrant to Docker and ahead as a checklist? So Pratik, we are having an entire there is a DevOps course guideline how we are going to move ahead. We are following that guidelines only how on this session. Okay, so you will get all the steps and all the topics that we are covering inside that from the DevOps course curriculum. You can refer to that. Okay. Now, guys, up till now, we have done the Docker. Okay, we saw the virtualization. Okay, now there is an another aspect where we are actually running the virtual machines, which was the case till now. The Docker came into picture just recently. Okay, so you will still see a lot of places the virtual machines are still being used, and all the applications are running on the virtual machine. Okay, now up till now whatever we have heard how we can package the application and everything, this is comparatively simpler to run everything, because you don't have to manage anything. You are just starting a container, okay, and then your application is up and running, okay. But when you are working on virtual machines, then there is no such container, okay. In that case, you will have to write everything in the form of YAML files. Okay, so the we are basically going to cover four configuration management tools, that is your Chef, Puppet, Ansible, and Salt. So all four of them will allow you to see whenever we are working on the virtual machine. It basically means we are configuring something like we are configuring the systems on which we are going to run our application, or we are configuring the application, or we are configuring the web servers or database servers, right? So it always comes down to the configuration. So the configuration management tools allows you to write everything in the form of an automation, where you can write everything in the form of the YAML files, and then these Chef, Ansible, Puppet, they can create the infrastructure from the scratch for you automatically. Okay, like if you wanted to install some dependencies, you want to install the nginx web servers, you want to add the users, configure the monitoring, deploy the code, so all of that thing can be automated using the configuration management tools. Okay, so the learning curve would be little more in the Chef and Puppet, because they have lot of terminologies which are specific to them. Both have been written in the Ruby, and then similar to them, then we will cover the Ansible and Salt, which are written in Python, and they are comparatively easier, and they are same. Anything which we can do from one configuration management tool, we can do it from other as well. Okay, so we are going to cover four of them later. The only difference between the Docker and those configuration management tool is that while Docker is used to run the containers, okay, the configuration management tools are used for the virtual machines, for managing the virtual machines. Okay, so that is what we are going to cover. All right, so that's all for the today's session. If anyone is having any doubt, you can ask now. Else, I will see you all in the next session. Everyone just get one VM ready for the next session, and then we are going to perform the lab for the Docker in the next session. Okay. All right. Thanks, everyone. Ending the session now. See you all in the next session. Yeah, Samiksha, tell me. So, Samiksha, whenever you are running the microservices, okay, you have to build the multiple microservices. You can have like 40 to 50 microservices running. Okay, so you will use the Docker, uh, like the Docker file or the Docker Swarm to create these microservices. So instead of running the virtual machines, you are going to run those microservices inside the containers. And because the containers are easy to create, and within one host you can deploy multiple containers, so you don't require so many virtual machines. You can easily create the containers using the Docker file and create those containers up and running. So your microservices would be deployed on those containers, and you can easily deploy your microservices on the less number of hosts. That is what we say, like in the microservices, Docker comes very effective. It is best suited for microservices kind of architecture only. Okay. Yes, so Vishal, each microservice, okay, will need one separate container. You are not going to combine multiple microservices inside one container. Always remember that one microservice will run on one container, and then another microservice will run on another container. We are not going to ever combine this. Okay. Yeah, so AWS is somewhat different in the sense that it's a way to create the virtual machines. So it's providing everything, but then how you are creating your containers, okay, this is up to you. How we are creating the containers, you can run anywhere. You can run on AWS as well. Okay. But then AWS itself is having a limitation that it's only supports the resources that is for the AWS. If you try to run it on Google Compute Cloud, then you won't be able to run it. Okay. So there is a platform dependency. All right. I hope that answers your question, Samiksha. That's all for today's session. Okay. Yes, once you configure the networking, then the Docker containers can talk to each other. Okay. We are going to cover that during the Kubernetes, where we are going to create our own network. Okay. And then whatever containers we are deploying, they will interact with each other, and Kubernetes is going to take care of everything about the interaction, how the network is being established, how the containers are deployed on which VM, and things like that. Okay. All right.